Swayam Prabha. Digital India. Educated India.
So, for example, there one example is Hamming distance. So, this is based on the amino acid composition, right. How to calculate the composition? N of I divided by N. So, what N is the total number of residues in a sequence, and this is any residue of particular type, any residue alanine or whatever 20 residues, right. Now, I get 3 sequences. So, how many clusters you can put in these three sequences, and which two sequences are close to each other? So, just we can use this formula, Hamming distance, this is equal to composition 1 of I minus composition 2 of I, take the absolute difference, I varies from 1 to 20. So, what is the different composition for sequence 1? How many residues? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I put simplicity, I put 10. But usually, what is the average length of protein sequences? Right, you can see the large crowd around 200 to 300 or 100 to 300. Average length is 315 residues, depending upon the sequences deposited in the uniprot database. Right. Also, I showed the graph connecting the number of residues versus the frequency. Mostly around 100 to 300 residues. Right. So, for example, if you take the, for simplicity, I use small peptides. What is the composition for A in the first sequence? 0.3, C0, D 0.1, E 0, F 0, G 0, H 0, I 0.2, K, K is 0.2, L 0.2, M no, N no, all are 0. Oh, okay. 0.2, 0.4, 0.6, 0.91. Then for the second one, 0.4, 0.1, E, F, G, H, I is 0.1, K 0.2, L 0.1, 4, 5, 6, 8, 9, there is one more, S 0.1. So, third sequence, so what is the composition for alanine? 0.1, no C, D 0.1, E 0.1, F no, G, H, I 0.1, K 0.1, L 0.1, M, N, P 0.1, Q 0.1, no R, no S, W 0.1, right. 1, 2, 3, 4, 5, 6, 7, 8, 9, one is missing, S 0.1. So, now we calculate Hamming distance between 1 and 2. What is the value Hamming distance between 1 and 2? Point 0.3. This is 0.1, 0, 0.2, 0.3, 0.4. Right, now DH between 1 and 2 and 3, 0.8, very high. So, between the 1 and 3, 1.0. So, we can have the different sequences, something is wrong, right. So, 3 different sequences, right. So, we can calculate the Hamming distance between any pairs. Now, if you see this one, which two sequences are close to each other? 1 and 2 are close to each other. If you see this one 1 and 2 they are close to each other because the value is 0.4. So now you can see the different sequences. Then if you have any specific threshold, right, for example if you threshold of 0.5, right, then 1 and 2 are close to each other, right, either 1 or 2, then we can take 3, right. You can make it a different clusters, and from each cluster we can take a representative data, right, and finally you get the non-redundant set of sequences. This one is Hamming distance. So another is similar to Hamming distance, you can also get the Euclidean distance. Okay, the difference between Hamming distance and Euclidean distance is, what is the difference? Is sum of squares. So you can take composition of 1 minus composition 2 the whole square, right. Here we do not care about the sign, then you have to take the root. So what is the value between d e of between 1 and 2? You have to get the difference, right, 0.1, 0.2, 0.3, 0.4, then you have to take the root, yeah, 0.1 square, that is equal to 0.04, 0.1 square equal to 0.01, right, yeah, plus 0.01 plus 0.01 plus 0.01, right, and take the root, this equal to 0.04, 0.2, right, this d e of 1 comma 2. How about d e of 2 comma 3? Point 2 and 3 is 0.09, right, 0.01, here it is 0, here it is 0.01, okay, 1, 2, 3 times. So that means 0.01 into 5. So that is equal to 0.09 and 0.05, that is equal to 0.14. So root of 0.14, this is equal to 0.4, 0.3, 0.3 something, right. So likewise d of 1 comma 3, what is 1 comma 3? So 0.04, this 0, this is 1, 2, 3, 4, 5, 6, 7 times, right, 0.01 into 7, so 0.11, so 0.11, this is equal to 0.3 something. So then this is the closest one. Here also you can find, okay, Euclidean distance, you can see this is the closest among these 3 sequences. So you can make any pairs and you can make any different clusters, you can use any cutoff, right, I can do that. This here we used the amino acid composition as a feature. Likewise we can use any feature to assign the clusters and you can obtain the non-redundant sequences, fine. So how to install the CD hit? So this is freely available and this program is very easy to install, right, and it will work with this Linux operating systems, right. So first you download the files and then unpack using the TR, and then you have to go to your directory, right, and you can install the program by using make, right, and then you can run the program. So it requires first you need to download the program, you need to unpack and then you have to compile and you got to run the program, right. This is the steps we use in when the compiling in any program, right, in the Unix systems. So how to run CD hit? Because this is the program, right, you put ./CD hit and this is the command we have to give. So what is for I? That is the input, right, we get this input file name, the DB gives the input file name, and what is O? This output, okay, this is output file name, okay, DB9 this is output file name, and here we give the C 0.9 and N minus 5. What is 0.9? This is identity, so which identity you require, whether 90% or 80% or 40%. If you need 40%, what you have to give? 0.4, right. For the example is 40%. And n equal to 5, what is n equal to 5? Word size. So, in this case we look for the pentapeptides, right, any pentapeptides, right, how many times each pentapeptide occurs within the sequences, right. So, depending upon the your sequence identity and the word size, so CD it will run and then give you the sequences. For example, this is a choice they use a default, say n equal to 5 for the thresholds 0.7 to 1, n equal to 4 they use 6 to 7 and 3 for 5 to 6, right. This is normal threshold we use, right, for running the CD kit. So, now we give the sequences. So, we have all the sequence FASTA format and we run CD hit, right, this is the input file, right, this is the input and here this is the output. So, with the 85% sequence identity and using the word size n. So, you can use any word size, right, here n equal to 5. So, then you see you will get the final data. Now, you will get the data, then you can use this data, right, for your any analysis. And if we now we have two sets of data, one is the redundant sequence, one is non redundant sequence. If you compare your composition or your any properties, you can see the difference between the non redundant ones as well as redundant ones. Also it depends upon how much your data is reduced. If you can see much reduction in your data set, then you can see much deviation from the properties what you calculate from the whole data set or from the reduced data set. If there is not much redundancy, right, already your data set is non redundant, then you cannot see much different, then you will get similar data when you analyze with the whole set of data or with the reduced set of data. So, there is another program, right, this is also widely used program. One of the applications of BLASTclust is you can get the data with any redundancy. Even if you want to have 20% identity or 25% identity, you can use with this BLASTclust. Okay, this is the standalone program which is available within BLAST, right, and you can use this to cluster either protein sequence or nucleic acid sequence. You can use it for both protein as well as the DNA sequences, right, to get the clusters. So, how it works? It first begins with the pairwise match and the places the sequence in a cluster. If the sequence matches at least one with the other, if two sequences have high identity, then if you are interested to threshold of 25%, which is more than 25%, you put one in the clusters. In the case of the proteins, they use BLAST P for the alignment. For the case of nucleic acids, which program they use? BLAST N. So, take the BLAST N to align the sequences. Then here this is the command which can use to extract the data, right. You can first get the program, right, this is using the standalone program, you can get the non redundant sequences using this sequence. So, here the same, I is the input file. So, in file is the input file and out file is output file. Then we get some numbers minus pt, minus L 0.9, minus bt, minus S95. So, what is T stands for? Protein. For proteins they put T. For example, they have the L equal to 0.9, right, and what is the meaning of L equal to 0.9? This is a coverage. So, this coverage is about, that is 90%. What is the meaning of coverage? Sequence coverage. For example, if you have one sequence, right, this is AITLVIK, right, yes. Now, you can see aligned only some part of the sequences, for example, aligned only here. In this case, what is the query coverage? Coverage equal to 70%. So, this how much coverage you can accept, and then you can see the S95. What is S95? Identity. You can see it is about 95% sequence identity. So, here you can restrict, right, with the sequence identity plus the coverage, right. What is the advantages of using coverage? Right. For example, if you have one proteins 100 residues, another protein is 200 residues, only some part, only 10 residues are aligned and 10 residues are same. If you do not use a query coverage, they align 10 sequences and 10 sequences are same. So, what will be the identity? 100%. But you see the query coverage, out of 100 it aligned only 10. So, coverage only 10%, that means all 90 are totally different, right. In this case they are different from each other. So, to include this information, right, they use the query coverage, right, in this program. Right now we discussed about two different algorithms, What are the two different programs? CD hit and the blast class. So there is another program that is called PISES, right. This is a protein sequence culling server to get the subsets of non-redundant sequences. Here we have different options, either you can use the protein sequences already available in this server mainly from the PDB, right, or you can give your own sequence, right. For example, if you want to give your own sequence, you can give the UniProt sequences in FASTA format. If you want to compare with the existing ones, then you can use the existing PDB data, right, and you can compare and you can get any non-redundant sequences. So how they get this non-redundancy? If you have the PDB sequence, they use the structural alignment and the side blast alignment. So what is side blast alignment? This is a kind of multiple sequence alignment, right. There is a position, right, specific iterated blast alignment. So they have the multiple sequence alignment by putting same sequences or similar sequences at the first, right. So they have this sequence alignment as well as a structure based sequence alignment. They combine together if you have the PDB entries. If they do not have these PDB entries, for example non PDB, then they get the sequence identity only from side blast. It is because structures are not known. So they have these side blast sequences, they do the homologous sequences, and this will give you the values and the non-redundant sequences using only the sequence information. So this you can use this to cull any protein sequences, right, at various ranges of sequence identities. So what is the input sequence for this PISES server? It takes amino acid sequence in FASTA format as the input and then give the non-redundant sequences. So this is the web server. So here you can submit your query sequences and you will get the output, right, either by email or you can get on, if there is less number of data, right, you can get it immediately. But the problem with this PISES server is it can handle only less number of sequences. There is some limitations about the query sequence. But in the case of CD hit or the blast cluster, you can give any number of sequences. It can handle huge amount of sequences. So that is the difference between the CD hit as well as the PISES servers. So this is the online tool. So if you want to get the sequences which are already available in this server, you can get it. Or if you want to create your own data set, so for example if you have 1000 sequences and you want to get the non-redundant sequences, right, in this case you can get this, access the server, right, to create our own list. If you click on that, right, this will ask for the different options, which one you want. So you can, if you have your own sequence, right, you can click the last one, right, here you can see your own file of sequences. Then if you submit, then you can get this next page, right. Here you have to paste or type your FASTA sequence in this text box. You have the sequences, you can give the text box here, or you can upload file. They have the upload file option, right, you can browse, right, from your computer and you can upload the file which contains amino acid sequences in which format? FASTA format, because it accepts FASTA format of any UniProt sequences. Then you can also give your options. What is the maximum percentage identity you want? 25% or 30% or 40%, right. So you can give the threshold as per your convenience, depending upon the problem, depending upon your initial data set and your requirement, you can set the threshold. Normally we give 25% as a threshold. Then they are asking about the chain length, whether we need to consider all the sequences or discard some short sequence and large sequence. So here we can give 40 or 50, right, because several proteins are more than 50 residues, only few exceptions, right. So in this case you can give you the minimum length. Why do you need the minimum length? This can avoid considering the peptides. There are many short peptides. In this case you can avoid these peptides from this non-redundant data set. Then maximum chain length, right, that also you can specify, right, for your calculation purpose, right. Then it takes all this information as input and if you submit, right, then this will give you the sequence. Here this is the complete sequence and this is the list. Okay, this is the list for the IDs, right. Okay, you can see the ID here, right, and here we give the complete sequences and here we can give the sequence IDs. So you can use the PISES to get the non-redundant sequences, right, but the only disadvantage of PISES is it can handle only less number of sequences. Then it use a clustering techniques, right, finally they give you the final set of non-redundant sequences. So, till now what did we discuss in the class, today's lecture? Yeah, first we discussed about the redundancy. So, what is redundancy? Right, we can see if there are same sequences, right, if one or more same sequences, right, which are present in any data set. If we construct in a specific data set with consists of 100 sequences, are there any sequences or any 2 or 3 sequences which share the common information with the high sequence identity. So, if we share high sequence identity, then these sequences are called redundant sequences, right. Then how to get the non-redundant sequences? So, for example, if you have 2 sequences with 80% sequence identity and a third one with this 30% sequence identity, if you want to have the sequences with more than 50%, right, then what will happen, what you have to do? From the first 2, right, it is very high, so we can keep one and discard another one, because if you have the same sequences, that will reduce a bias in the final calculations as well as for any prediction algorithms. We check 2 examples, like what will happen if the same sequences are present 2 times or 3 times, depending upon the features, right. Some of them are over represented and some of them are under represented, right. So, in order to avoid the bias, we need to construct non-redundant sequences. So, what are the various program we discussed to construct the non-redundant sequences? CD hit, blastclust and the PICES, right. So, what is the advantage of using CD hit? It can handle large data sets, it is very fast. So, what is the disadvantage of the CD hit? Yeah, it can handle up to 30 to 40% sequence identity, because it has 2 versions, one is online and one is the standalone version, right. So, you can handle only up to 30% or 40% sequence identity based on the program you use. So, what principle it used for clustering the sequences? K-means clustering, right. They use the K-means clustering, right, to make these clusters, right. How this K-means clustering works? It considers all the sequences, right, and make into some desired number of clusters. So, let us K clusters, right, and then try to put in these similar sequences within that particular cluster, right, and then rearrange all the values again and again, so that the minimum redundancy is maintained, right, within that particular cluster. This take any cluster, you can see that is completely close to each other. Then they take the representatives from different clusters. In this case, you can get the minimum redundancy among your sequences. So, what are the various features we use for clustering techniques? We discussed 2 aspects, right, both are based on this amino acid composition, right. So, one is the Hamming distance and the encoding distance. So, if you have any pair of sequences, you can calculate the values and make any threshold. If the pairs are more than that threshold, then you can discard one, right. So, in the getting the non-redundant sequences, there are some advantages, some disadvantages. For example, if we have 100 sequences made into 10 clusters, first cluster has 20, second cluster has 5 and another cluster has 1, then how to get the representative data? If it is 1, it is easy, you can pick it up. If that is 10, how to get the representative one? Generally they will take randomly pick up one, right, you can get this one. This is the reason if you have to cluster again and again, and you can see what will happen if you pick up these different sequences from each cluster. You can see almost they are in similar features, so you can get similar data, right. Even then you can do this test to confirm that your data are significant or not. So, then the second one is a blastclust. What are the advantages of blastclust? It can also handle large data sets, and you can go with the less sequence redundancy, even 20%, 25% you can do, and can also consider the coverage, query coverage, right. So, that you can use the blastclust for clustering the sequences. The third one we discussed about PICES, right. Here it is easy to use, because if you give the all the sequences online, you will get the non-redundant sequences, right. But the only disadvantage is it can handle limited number of sequences. In this case, you have to do this again and again, take your sequence and get the non-redundancy, right, and then make another set and get the non-redundant sequences and come cluster together and put again, right. You have to run again to get the non-redundant sequences. So, we discussed about the construction of non-redundant data sets, right, and various features of the primary sequence, right. There are various parameters we calculated and we used for different applications, right. Now, in the next class we will discuss about the next level. What is next level of protein structure? Secondary structures, right. What are different secondary structures? Alpha helices, beta sheets, strand, coil and all, right. So, we will discuss about what are the different secondary structures, right, what are the probable allowed positions of these secondary structures, right, in the construction of Ramachandran plot, right, how to predict these secondary structures from any given amino acid sequence, right, what is the reliability of these prediction techniques and so on, that we will discuss in the next following couple of classes. Right. Thank you for your kind attention.